the mean. And so, for example, in our case, if I took the lowest piece of data, it's what, 61 minus 81.9. I think the next piece of data is 67 minus 81.9. And we do that all the way down to 104 minus 81.9. And that's all the deviations. Question? Yes, no, makes sense? Now, I want to get a sense of the total deviation, not just each piece. So I'd like to add it up, right? In other words, I want to see what the total spread is. So I want to add them all up. So we're going to run into a problem if we add all those numbers up. If I do this 30 times for our data, and then I add up all of the numbers I get, what's the answer to the sum of all these things? Without even using your calculator, what's the answer? Huh?
0.
Yeah, why 0, Nick? Who said 0? You or Tyler? You said 0. Great guess then. And Nick is absolutely right. It's 0. Why is it 0? No, don't divide by anything, just add them all up.
Because the mean is all of the entries divided by 30, so if you add all the entries up, minus subtract each one by 81.9, it'll cancel
Oh, is
out.
that what you were going
That's
to?
what I was going to say.
Okay, all right, fair enough. Yeah, you're absolutely both right. The answer is 0, because that's how you figured out the mean. And if you think about it, the mean is the middle for a purpose. It's like a seesaw, right? In other words, you got some data that's on the left side, 61 minus 81.9, that's a negative number, right? And then you got a bunch of data on the right side, and the mean is supposed to be the balance point right in the middle. So you add all the people up from the left, all the people on the right, it's got to cancel out where you wouldn't have the middle. So they add them all up. What seems like a really good idea to add up the whole spread, we get screwed up because the sum is 0. So how do we fix that a lot in mathematics? Anybody ever heard of the Pythagorean theorem? What's the Pythagorean theorem? Anybody? A squared plus b squared equals c squared. That's great. How would that mean? What is that?
The line between the right angle
Hypotenuse?
and the other one equals the hypotenuse. I don't know how to solve
Right,
it.
right. But we go a squared plus b squared equals c squared. And the reason we do that is because we don't want to have any negative distances, right? We want to make sure that we got everything as a positive number. And the relationship in coordinate system means you could have some negative distances, okay? If you actually said, I go from here and I go to here, it might be negative, but I don't want any negatives. I want to have this idea of everything being contributed to a positive number. That's why I have squares. So we use the same trick here. We square everything. And so we say, essentially, the square of everything on the left side has got to equal the square of everything on the right side, but they're all now contributing to this description of how varied the data is. So we square them all. And then we add them all up. So let me give you the formula. I'll show you on the screen in a minute, but the formula is the sum I equals 1 to n of xi minus mean squared. And I divide by n minus 1. Oh, how come it's n minus 1? How come I don't divide by n? Why not divide by 30? Well, that's kind of a mathematical trick, which I'll explain in a minute, but if I do that, this is called a sample variance. Now, it looks very mathematical. I know there's a formula. I know sample variance sounds like it's very statistical, and it is, but it's just the sum of these distances that all the data is away from the middle. The measure of distance is all it is. how spread out are all the data points? It's like saying, how spread out is all the relatives, okay? They're all the data points. How far away are you from the middle? That's all that's going on here. All right, so let's figure ours out. I do not want you to do this calculation 30 times by hand, okay? So I don't know if you have your data still in the calculator from last time or not. I am fortunate, I do. How many people have their data in there from last time? How many people need a moment to get caught up? Okay, so we'll give you 1 or 2 minutes, but for the rest of you, figure out how we're going to just do this in one fell swoop. If you don't want to do this 30 times.
There's an option of this.
There's a what?
There's a button somewhere.
There is a button somewhere. Yes, Tyler.
1 bar stats.
No. Well, yes, but not yet in this class, okay? You're 45 minutes ahead of me, okay?
As a variance on the second stat.
Yeah, here's what I meant. I meant go to list 2 and go above the bar. List 2 above the bar. And let's put a formula in for list 2. And let's say I want list 2 to be, you notice I'm putting a formula down at the bottom here. I want you to say, where's X? Where's the data points? List 1. What do I want to subtract off from list 1? Mean, but what's the mean in our case? 81.9. And what do I want to do with that when I subtract, subtract it off? Minus 81.9. And when I get that deviation, I want to square it. Now if I hit enter, I should have all of these squared, they're actually literally called the sum of squares. When I add them all up, I should have all the squares in list 2. Anybody have numbers that look like that? Brandon, yours look like that? Anybody not have numbers that look like that? Dominique, you okay? Like that? No, they don't look like that?
No, I didn't see the formula.
Do the formula.
No, I didn't see.
Yeah, what was the formula for the?
All right, let's go back, okay, so just, okay, I'm gonna clear list 2. And so, bear in mind that for us, I wanna calculate this, I wanna put it in list 2. All of my data elements, mine are what? In list 1. And in our case, X bar is 81.9, right? So I'm just going to put a formula in. I'm going to go up above the bar and say, put a formula in for list 2. List 2 is going to equal list 1. Well, I want to put parentheses. List 1 minus 81.9, and I want to square that and populate it. Okay, so now I got this 2, that's the squares that I want to add up. If I want to add them up, I'm going to quit out of here, I'm going to go to second list. Remember from the other day, over the math, I want to sum up list 2. And if you add list 4, anybody get a number like that? That look right? Yeah, looks good on this? Okay. So what do I have now? That number is the numerator, isn't it? That number is the numerator. Jalen, you got your calculator?
Sounds good.
Okay. You must feel naked. I'm sorry, I have this vision, if you come to stats class without a calculator, you should envision yourself sitting there nakedly exposed. It's a horrible image. Okay. I'm not trying to embarrass you, but a little bit, okay, because you need it. It's good to see you got your cast off, too. All right, so we got the sum here, that's 24.699. Now we need to divide by n minus 1. What's n minus 1 in our case? How many data points do we have? 30, so this is 29, right? So we're going to divide by 29, and what number do we get? I think we get 85 point something, right? 85 point what? All right, so I'm going to divide by 9, and put 85.2, round off. Okay, so our sample variance is 85.2. And the symbol for sample variance is S squared. So sample variance, which is S squared, our sample variance is 85.2. Questions on how we got there? Now, we have kind of the sum here, but if you recall, when we got that, we squared all these things, right, as part of the process. So now we try to come back to kind of our real measurement, and we take the square root of S squared, and that's called the sample standard deviation. So we're kind of unsquaring the distances. So if I take the square root of that, that's called S, and what's our sample standard deviation? What's the square root of 85.2? Tyler? 9 point what? 229. 9 point, if I go 9.2, is that correctly rounded off? Everybody get that? Everybody okay with 9.2? So I have the standard deviation, and I have the variance. So before we go on, I just need to, again, emphasize the difference between what we've talked about in terms of sample and population. The sample variance is S squared and S. The population variance and try not to get panic stricken when I say population and sample, but the population variance is the same formula, except there's